we're going to visit the Three Gorges Dam. It's the largest hydropower dam in the world. Have you ever imagined a ship sailing above mountains? With China's astonishing ship lifts and canals, vessels weighing thousands of tons are defying gravity and ascending into the sky, something you wouldn't believe unless you saw it yourself. But how can a ship weighing as much as a skyscraper be lifted hundreds of feet above the ground? What kind of technology makes this possible? Time to find out. Dams are powerful tools for generating electricity, controlling floods, and storing water. But they also create enormous barriers by blocking the natural flow of rivers. This wall divides the river into two distinct sections, upstream, where water piles up into a vast reservoir, and downstream, where the water level can be significantly lower. The result is a dramatic elevation difference between the two sides of the dam, ranging anywhere from a few meters to over 100 meters depending on the dam's size and purpose. And here's the core issue: ships rely entirely on the continuity of the river. Without a way to traverse this elevation change, the river is effectively split in two, bringing maritime trade and transport to a halt. This disruption not only affects cargo movement but also the communities that depend on river routes for economic and daily activities. It turns what should be a seamless journey into a dead end unless there's a solution. Historically, the solution to the problem of elevation differences created by dams was the use of locks. Locks are essentially giant water-filled chambers with gates at either end. Ships enter these chambers, and the water level is either raised or lowered to match the next stretch of the river, allowing vessels to continue on their way. The use of locks to solve elevation differences in rivers dates back centuries. In fact, the first grand lock we know of was constructed in China during the 10th century, known as the Grand Canal's Doublegate Lock. But here's the catch: locks have their limits, especially when it comes to very high elevation differences like those created by modern megadams. Imagine trying to build a staircase that needs to climb the equivalent height of a 30-story building. You would need countless steps, or in this case, a series of multiple locks. This becomes impractical for several reasons, such as the cost, space needed, and the time it would take to go through different locks. This is where ship lifts come into play as an elegant and efficient solution. Unlike locks, a ship lift can handle a large elevation change in a single operation. Imagine an elevator, but for massive ships weighing thousands of tons. Instead of waiting hours to pass through a series of locks, vessels can be lifted or lowered quickly, saving both time and valuable resources. And there's no better example of this than the colossal Three Gorges Dam ship lift. As one of the largest ship lifts in the world, it's capable of elevating vessels weighing up to 3,000 metric tons. Imagine lifting something as heavy as 500 elephants, about the same weight as a small skyscraper, 113 meters, 370 feet, up in the air, all in just 40 minutes. This makes crossing the height difference created by the dam efficient and surprisingly quick compared to the traditional 5-stage lock system, which could take 3 to 4 hours. This boost in efficiency is crucial for a dam of this size, located on the busy Yangtze River. Since its opening in September 2016, it has significantly increased the river's freight capacity, allowing for safer and faster shipping while also cutting shipping costs by 25%. The ship lift is a complex piece of technology with some remarkable specifications. The lift chamber itself is like a giant floating bathtub filled with water, measuring 120 meters long, 18 meters wide, and 3.5 meters deep. The entire structure is suspended by 256 ropes, each connected to 128 double rope pulleys that balance the lift using counterweights. These ropes are anchored to the tops of four massive reinforced concrete towers, each towering 169 meters high. This intricate combination of counterweights and ropes allows the ship lift to move with the kind of efficiency and reliability needed for such an enormous task. While the Three Gorges Dam ship lift is an impressive engineering marvel, it's not the only large-scale lift redefining river navigation in China. Another major project pushing the boundaries even further is the Goupitan ship lift, currently the world's largest ship lift, capable of elevating vessels weighing up to 500 tons to a staggering height of 199 meters, 653 feet. That's taller than a typical 60-story building. This impressive capacity makes the Goupitan lift crucial for enabling smooth river navigation across China's rugged interior. Its sheer lifting power is key to connect the Wu River with broader economic networks. The lift system consists of not one, but three interconnected lifts. The first, a vertical boat lift, is a variable height lift capable of moving vessels between 72 and 79 meters depending on the downstream water levels. The second, another vertical boat lift, has a fixed height of 127 meters, making it the tallest single boat lift in the world. The third, the upstream vertical boat lift, has a variable descent height of up to 47 meters depending on the reservoir water levels. The Goupitan system is designed to be both powerful and fast, with each of the three lifts having a lifting capacity of 1,800 tons and a lifting speed of approximately 8 meters per minute. This means that a 500-ton vessel can be raised or lowered in just 10 minutes. But what really sets the Goupitan ship lift apart is the network of elevated aqueducts and tunnels that connect these lifts. Spanning a total distance of 2.3 kilometers, 1.4 miles, this elevated canal system, suspended 100 meters, 328 feet, above the ground, gives the lift its surreal quality. Ships quite literally sail above mountains, gliding through channels suspended high in the air, making it look like the vessels are floating over the landscape. This distinctive feature is one of the primary reasons the Goupitan ship lift has gained so much attention, with images and videos of ships seemingly walking on an overpass going viral worldwide. Beyond China, other ship lifts around the world have also demonstrated remarkable engineering feats. In Russia, the Krasnoyarsk Dam ship lift, in operation since 1976, moves ships weighing up to 1,500 tons up and down a height of 101 meters, 331 feet, using a slope track, similar to a slow-moving roller coaster. Belgium's Strépy-Thieu boat lift, one of Europe's tallest lifts, boosts boats up to 73.15 meters and connects two major river basins, greatly improving transport efficiency. Scotland's Falkirk Wheel, the world's only rotating boat lift, connects two canals 35 meters apart in height and dramatically reduces travel time by eliminating the need for 11 locks. In the United States, Mobile, Alabama is said to host the largest ship lift on the Gulf Coast, capable of handling vessels over 18,000 long tons. Meanwhile, Australia's $215 million Darwin ship lift will be the largest in northern Australia, lifting vessels up to 5,500 tons for ship repairs and naval maintenance. Lifting ships that weigh thousands of tons to incredible heights might seem like magic, but it's all thanks to clever engineering. The key lies in a counterweight system. Just like an elevator in a building, the ship lift balances weight with massive counterweights. Thanks to Archimedes' principle, the chamber's weight remains stable whether it contains just water or a ship plus water, making lifting easier. Powerful electric motors provide the necessary force, such as the Three Gorges Dam ship lifts for motors, each generating 320 kilowatts, for a total of 1,280 kilowatts, enough to lift a skyscraper's weight. The chamber is connected to counterweights by steel cables and pulleys, ensuring smooth movement. The Three Gorges Dam, for example, has 256 cables, each capable of supporting 460 tons. Advanced computer systems control lift speed, positioning, and stability, adjusting for water levels and wind conditions. And that concludes today's video. If you want to learn about one of the most important locks in the United States, Check out our video on the Saloxin Salt Ste Marie and the mega project aimed at preventing a potential $1 trillion disaster. If you're interested in dams, watch our video on the most expensive and largest dam removal in US history, the Klamath River Dam removal. Thank you for watching, and see you in the next one.